So today's session is one of our Skill Me Up expert talks, and this one is all about business continuity with Azure Backup and Azure Site Recovery. So let's dive in. For those who don't know me already, my name is Jonathan Tuliani. I'm the European Managing Director for Opsagility. I have been with the company coming up on 3 years, maybe a little bit less. And before this, I was a technical program manager over in Microsoft for nearly 10 years. And most of those 10 years were actually in the Azure product group. So I worked on the initial release of Azure IS VMs. I used to be responsible for the Azure DNS service and the Azure Traffic Manager service and various other DNS bits and pieces. So long experience in Azure, and now I spend my time with Opsagility helping Microsoft's customers make the best of Azure, using sharing that knowledge from those days, and everything that's new since then. I'm also one of the authors on the Microsoft Azure Administrator exam reference book. You can see the little picture there, and I'm a certified Microsoft trainer. Do feel free to connect with me. My LinkedIn details are there on the slide, and my email address also if there's any follow-up questions. Okay, so we're going to make this one of our Skill Me Up expert talks. And what is an expert talk? So this is a session. This one is booked for 2 hours, but we'll see how we go for time. But roughly that kind of duration. And the idea is that it's a deep dive, practical exposition of how to achieve a particular goal. Focused around a particular topic. And in this case, of course, the topic is all around high availability in infrastructure as a service. So that's what we're going to be deep diving into. I'm very happy to keep this a little bit interactive. If people do have questions, then do drop them in the chat channel, and we'll also have some Q&A at the end. So what are we going to talk about today? We're going to talk first of all briefly about just high availability in Azure, and then we're going to spend quite a long time on Azure Backup and then on Azure Site Recovery. So that's we're going to go fairly deep into those two services, and then, as I say, Q&A at the end. So let's start with high availability and start with just a brief introduction to the topic. And we'll start by thinking about why resilience matters. Why are we doing this? Now everyone here probably knows the answer to this. That's why you're here in the first place. But let's just make sure we're all on the same page. You can see things with as more and more services move to the cloud. You have evolving threats that are, attacking the cloud landscape, evolving threats in IT generally. You have more and more accountability, more and more business critical services moving to the cloud. Creates a bigger attack surface, creates a bigger, more attractive target, and also a more critical target to defend against those threats. Because if things go wrong, then of course we have issues with customer trust. We have issues with the brand of the company offering the services, and also for individuals on this call, most likely, potential issues with your IT career and your credibility. I mean, it's our job as IT practitioners to make sure that our services are available. So this is a critical area. It cannot be ignored. I always say when I talk to customers that there's many aspects to any Azure deployment, and sometimes, for example, performance or scalability is critically important, but for some services, not so much. They're relatively small scale, and they're not likely to move away from that. But I always say that there's 3 things that everybody cares about, and one of them is availability. Everybody cares about availability, and the other 2, everybody cares about security, and everybody cares about cost. So those are the critical things that I always see everybody cares about, and this is one of them. So let's make sure we're all good at this stuff. Okay, so when we talk about resiliency, I think of it in 3 different buckets, and that's the way we're going to present it today. And they're kind of overlapping scenarios, and it's easy if you're relatively new to the topic to kind of mix these up a little bit. So it's important to just get really clear on these distinctions. And also it's a useful way for us to make sure we're speaking the same language, using the same terminology. So the first one, high availability. So this is enabling your application to stay available even when the routine day-to-day stuff hits. So, a power supply blows on a server, or maybe you're doing routine maintenance and patching, or rolling out a new update of a new version of the software. A network card blows, a network device breaks. This kind of stuff happens all the time. And, the way that the general strategy for avoiding these kind of failures and keeping your application running smoothly through these failures is just having some redundancy, running more than one of everything, and spreading things out so you don't have a single point of failure. And this happens, of course, people have been doing this for many, many years in their on-premises IT. And of course, we have features to do this in the cloud, which we're going to talk about. In particular, availability sets and availability zones, and when you're using outside of IaaS, just highly available services. So avoiding single points of failure, having that redundancy, that's key to just avoiding these routine issues. The second scenario there in the middle of the slide is backup. So this is dealing with data loss or data corruption. Maybe you're attacked by malware. Maybe somebody deletes data. Maybe they do it maliciously, an insider. You know, they're having a bad day. They had an argument with their boss. They're leaving the company. They've done something bad to your data. Also, long-term data retention comes into this bucket. That can be a compliance requirement to keep logs for 7 years or whatever the duration may be. So here, the strategy, of course, is data backups. You know, making copies of your data and storing those copies securely. And this is where the Azure Backup service comes in. And we'll talk more about the Azure Backup service as we go along. You can also make snapshots of your disks, and we'll talk about geo-redundant storage as well for backup as we go. And then the last scenario there is disaster recovery. Now, this is often confused with the first scenario, the high availability. So high availability is about routine failures. It's about the day-to-day stuff that breaks. And here you want your service to just sail over those bumps as if they weren't there. Your customer doesn't notice. Disaster recovery is a different scenario. So here we're talking about major outages, floods, fires, earthquakes, power failures, you know, major disasters that don't just affect a single server, but take out an entire site. You know, an entire data center is powered down, for example. So this is where you have to decide what your strategy is going to be. Now, some people will run active across multiple sites in order to protect their customers from the outage. That can be done, but it tends to be quite a complicated solution and quite an expensive solution. So for most applications, the legitimate scenario here is to simply have a standby site available and accept that there's going to be some downtime as you switch over from your normal site to your standby site. Obviously, your data is going to be replicated across to the standby site, and the standby site needs to be a certain distance away. So, you know, if a large storm hits and takes out your site, then that storm, you know, Hurricane Sandy in New York, for example, that your standby site is far enough away that it's not affected by that same event. As a result of that, of course, you're going to have data replication between the two, and with that kind of distance involved, that data replication probably won't be synchronous. So you may be looking at some small amount of data lost there, and obviously the less the better. And that's where terms like recovery point objective, which is how much data do I lose in a scenario like this when an accident happens, and also the recovery time objective, how long does it take me to get the service up and running again? Those two terms come in, and in many cases we're looking at having a low RPO, recovery point objective, and a low RTO, recovery time objective. Okay, this is implemented with Azure Site Recovery, and this scenario also overlaps with a different scenario, which isn't an availability scenario, which is migration. Some people use these kind of tools, Azure Site Recovery and others, as migration tools in order to move a workload one way with no plan ever to fail back again. So there's an overlap with the migration scenarios, but we won't be talking about migration any further in today's expert talk. Okay, so those are the three pillars that we're going to be looking at. The way Microsoft phrases these in an Azure context is they talk about this resiliency continuum. And this is an image taken from a nice PDF that they have. There's a link on the right of the slide there. If you go to that page, there's all kinds of information about Azure's resiliency scenarios. And there's a link fairly near the top of that page, which takes you to the PDF that image has come from. And this is this resiliency continuum. It starts with a single VM over on the left-hand side. And here we have Microsoft offers an SLA for a single VM, which is 3 nines SLA, but that only applies if you have premium storage attached to that VM. It doesn't work with standard storage. And then on top of that, the next stage up is where we talk about availability sets. And this is where we have multiple VMs that we distribute around the data center, and that protects those VMs from any of those single points of failures we talked about, and also means that they get maintained on separate cycles so that they don't get all shut down for reboots at the same time. So that's your availability sets. That gives you the 395's SLA. Availability zones is where we move up a notch again. And here we're still within one Azure region, so we're still close enough together to write data synchronously. But the zones are spread out across different data centers that have a certain distance between them. And as a result of that, we have protection against those disasters such as fires and power failures and cooling and that kind of disruption. So that's your availability zones, where you spread your VMs out, across those data centers, across the availability zones within a region. And the last one there is when we talk about region pairs, or even if they're not paired regions, just regions across multiple Azure sites. And this is where we're protecting against the kind of disasters that will take out an entire region, the tornadoes and earthquakes and the large scale disasters that would affect an entire region. So it's all about what you're trying to defend against. Obviously, costs tend to go up as you move to the right on the chart. So it's all about, what are your business needs? What are you trying to defend against? This is where it's important to choose where you need to be on this continuum. And we're going to talk about the various technologies available to implement our protections. On that last one, we talk about paired regions. Paired regions are interesting. So if you think about it, Azure has a documented list of how each region is paired. So for example, West Europe is paired with North Europe and so on. South Central US, North Central US. So you have these different pairs. And even if you look at the Azure map, you can see these pairs popping up there. You can see in Japan, there's a couple of regions. In Australia, there's originally 2 regions and now going to 4 regions. You can kind of see the pairs, how they're put on the map. The recent launch in South Africa or Norway, again, a pair of regions, within these countries. So those pairs are they are intended to help you with these resilient scenarios. So for example, if you're using Azure Storage and you use geo-redundant storage, which we'll talk about a little later, it replicates to the paired region. Now, for some other storage technologies, such as if you're using SQL database, you can choose where the database will be replicated to. So you can choose any region you like, but you still may like to choose a paired region because there's other aspects of paired regions that are also relevant. In particular, new updates to each service are rolled out separately in paired regions, because one of the things that can cause a failure is if an update is rolled out that happens to have a problem with it, or a mistake is made during the update. Now, Microsoft's pretty good at this stuff, but it does happen. So any change is obviously a potential risk, potential cause of failure, and that's where paired regions are updated at separate times. So again, it helps protect you against an outage caused by some kind of change management or bug that gets shipped. So that's where, again, using paired regions is important. Okay, let's go on to the next slide. Okay, so availability sets, we said, was the second tier in that availability continuum. And this is where we will create an availability set, and we, as a standalone resource, and we deploy our VMs into that availability set. And when you do that, firstly, the availability set must be created first, but secondly, the VMs are associated with that availability set at creation time, and it's kind of permanent. You can't change that association later. You can't create a VM and then decide, oh yeah, I should have put that in availability set and move it over at a later time. It's a one-time operation at VM creation time. So this separates your VMs within the data center. And also when you're using managed disks with your VMs, which everybody should be, I assume no one is using out and managed disks at this point. They're many years obsolete. When you use managed disks, they will also be spread out into separate storage clusters, so they're also protected. So both storage failures and VM failures shouldn't affect all the VMs in the same availability set. There is a special setting on the availability set to enable it for disks, but that will be set by default if you're creating the VM in the portal. But just be aware there is a special setting there if you're creating VMs via a template or something. It also helps protect your VMs against updates that are being shipped in Azure. Updates are obviously rolled out incrementally across the platform, and when you're in availability sets, your machines get updated at different times. And this ability to protect against failures and updates is achieved by dividing the machines into what's called fault domains and update domains. You might have a large availability set with 100 VMs in it, say. Obviously, it's not the case that Azure will update all 100 at different times. That would take an awful long time. But what it does is it groups the VMs into update domains and groups them across fault domains. So potentially a single update or a fault might impact this more than one machine if they're in the same fault domain or the same update domain. But that generally only happens where you have a larger number of machines that's larger than the number of your fault domains or update domains. I think 3 and 5 are the default values. So do use availability sets. They are a great way to help protect your workloads. Moving up along that continuum is availability zones, and this is where we're splitting our VMs across the different data centers within a region. For example, if you look at the Paris region, the France North region, you'll see that there's a data center towards the north of Paris, another one to the south of Paris, another one to the southwest of Paris. So they are significantly spread out to protect and give that isolation in case of fire, cooling, someone putting a digger through the network cable, this kind of thing. They're well protected from these issues. What's nice about the way availability zones have been implemented in Azure is that there's no impact on the network architecture. You can still design your virtual network and your subnets without having to think about your availability zones. Your subnet can just span the zones and it all just works. So they're kind of independent design elements. In AWS, your availability zones and your subnets will be mapped together, whereas here you can just have an availability zone, use your availability zones independently of your networking, which is great. You also have the ability to use a zone redundant load balancer and a zone redundant public IP address. So you can easily load balance across VMs that are spread across the zones. One of the things that is sometimes confusing for people initially is if we go back to the availability set model, in this case, you created an availability set as a resource, and you then assigned multiple VMs to that one availability set. And what that did was it spread the VMs out. So you put them into an availability set, but that didn't kind of bundle them together. That actually spread them out. Now, if you actually want VMs to communicate very fast with each other, there's a feature called proximity placement groups that can do that. But that's an aside. We don't need to worry about that from an availability point of view. But the point is the availability set spreads out the things in that set. Whereas with availability zones, there's no such resource as an availability zone. You don't create an availability zone. Instead, it's just a property. On the VM, you specify this VM goes in zone 1, please. And then on the next VM, you say, put this one in zone 3, please, or put this one in zone 2, please, and so on. So you specify the zone explicitly. It's not a resource. And therefore, if you put all your zones in zone 1, well, then they're not spread out. If it's your job to explicitly assign the zone to each VM. And your job to spread them out. So that's a very different model to the availability set model, where the spreading is done for you, and you actually put them into the same availability set to spread them out. So make sure you're clear on those two different. Okay, super. Let's keep going. Do feel free to jump in with questions. By the way, of course, we're open to questions, and also in the chat, there's a chat channel you can put questions in. Let's keep going. Okay, we've been talking about failures. It's important also to understand the story around maintenance in Azure. And this is something that's, if I go back to the early days of Azure, used to be to be honest, a weak point, but it's something that a lot of investment has been made here. And I have to say, it works very, very well now. They've really turned this story over, and it's really, I'm very impressed with it. So your VMs are, well, the clue's in the name, right? They're virtual machines. That means they're virtualized. They're running on a physical host, which has its own operating system. It's running the hypervisor that your VMs sit on top of. That's always there. Now, you don't have to worry about it. That's what Microsoft has to worry about. But the thing is, that host still needs maintenance. So what's the story there? How does Microsoft maintain these hosts? And what does that mean for your VMs that are running on top of those hosts? Most of the updates that Microsoft ships, Microsoft makes a lot of effort to make these low impact for you. So most updates are what's called memory preserving. So these are, and most of these updates are also zero impact. In other words, Microsoft can deploy the update and nothing happens. Everything just still works. You don't notice, your VM keeps running, no impact. Great. Now, in some cases, in order to do this memory preserving maintenance, your VM may be paused. It's only in some cases, it's not all cases, but in some cases you may be paused. Your VM may be paused and then it'll carry on just where it left off. Now, that pause is generally less than 10 seconds, although it could be up to 30 seconds. And that's, again, just a slight pause on your VM. If you're in availability sets, of course, they'll be paused at different times. And that principle of doing things at different times also spans across availability zones. Now, in some cases, Microsoft isn't able to do that memory preserving incidents where the VM is simply paused. And in the next option that Microsoft has is to live migrate your VM to a different host, obviously a host that's already been updated. So this is where a small minority of updates are handled this way by live migrating your VM to a different host. But this is also used in some other scenarios. For example, if Microsoft needs to do some hardware maintenance on the host that's hosting your machine, maybe that hardware is being replaced, and also maybe Microsoft has detected that hardware may be likely to fail in future. Microsoft monitors their hardware very closely, looks at a lot of data regarding temperature and fan speeds and various other data it can get. And often it is able to do proactive maintenance. It can detect that the hardware is unhealthy before it actually fails, and will proactively live migrate your VMs to a different host that is healthy, in order to keep you that high availability story. So you don't see that hardware failure until when it then happens later on. So that's proactive maintenance. So this is done with live migration. Typically this takes under 5 seconds, and again, all you'll experience on your side is a slight pause in the VM for a few seconds. And the temporary disk, because the VM isn't being rebooted, Microsoft aren't going to yank the temp disk out from under you. The temp disk is migrated at the same time. Now, these two approaches we've mentioned, memory preserving and live migration, they are not supported on all VMs. You can see here the G, M, N, and H series VMs are not supported. So occasionally Microsoft has to take the third approach, and this is where your machines are going to be rebooted. Now, it may be that you're rebooted in place, in which case your temp disk is preserved, but more likely you're going to actually be rebooted and spun up on a new host, in which case, of course, your temporary disk is going to be lost. So but bear in mind, the temp disk is temporary. You can lose it anytime. So this is for occasional planned updates. When these are planned, this is also it's planned well in advance, and you get given, for these reboots, you get a 4-week maintenance window, and you'll get notified of this window, and you get to choose what slot you want to use in that window for your migration, for your update. And at that time, the time that you choose, your VM will be migrated to a host that's and rebooted on a host that's already been updated, and of course, when every VM has gone from the old host, and that one can be updated itself. So this is the maintenance window story. If you don't choose a slot within that 4 weeks, then Microsoft is just going to say, okay, we're doing it for you. They might not do it immediately, but it's now outside of your control, and they are going to implement this for you. I see there's a question there on the channel. Is there an alert or email when the host maintenance occurs? That's a fantastic question. So on the reboot, yes, that will be notified by email to the subscription owners, I believe it is. So the reboot gets a notification. Now, there's no email notification for the other ones, the memory preserving and live migration. But if you go to my next slide, what there are what's called scheduled events. And this is an API that is available within the VM. So from within the VM, you do an HTTP GET request to that magic URL. That's a special kind of non-routable IP address that the platform reserves. So you call that API within the VM, and you get back this data that looks a bit like that response that you see there. The document incarnation, that's just an ID, so you can see if you've seen this piece of information before. It's just a random number that changes when the information changes. So it's just to avoid you having to deal with duplicate information. And you can see there's an event ID there, and then you get told what kind of change is happening. So a reboot is when you're going to stay on the same machine and you're not going to lose the temporary disk. A redeploy is when you're going to reboot on a new machine and you are going to lose the temporary disk. A freeze is where the machine is being frozen, either for a live migration or for the in-place memory preserving update. And a preempt is if maybe you're running a low priority VM and you're being thrown off the server to make capacity available for someone else. That's part of the deal with these low priority or spot VMs. Terminate is you're being terminated. Maybe you haven't paid your bill, for example. So this then shows, it's a virtual machine that's happening, and it shows whether it's just in a scheduled state or a started state. It shows you which VMs it is, and it gives you a not before time, says you when it's going to happen. And this information, you'll find the documentation page on this easily enough, and just search for scheduled events, Azure scheduled events, and you will see that this information is typically posted between 5 and 15 minutes in advance. You might get longer, but maybe not. So and it depends on the event type, where it sits in that 5 to 15 minute range. So if you're very sensitive to even those short VM freezes, then your VM should implement some kind of polling against this API. The idea being that this enables the VM to take preemptive action against those kind of changes. those kind of pauses and so on. So there's the notification that you have even for the pauses. As I say, for the big ones with a reboot, the scheduled maintenance on the reboot, you do get the email notification. The reboot, of course, also applies where you have an unplanned outage. If a server suddenly blows up, well, of course, your machine is going down. In that case, Azure will do what's called service healing. It will recognize the failure and it will spin your VM up again on a new host. That will take a couple of minutes. Obviously, depends how big the VM is and so on, but it's generally a pretty quick operation. Obviously, you'll lose the temporary disk and you'll lose whatever you were doing at the time, but your machine will service heal and come back to life within a few minutes on a new host in the event of just a plain old hardware failure. Okay, let's keep going. Did that answer the question, by the way? There was, like I say, the question on the alert or email. Does that answer the question for you? Oh, super, thank you. Okay, so storage, I think most people are probably familiar with this, but let's just run through it quickly. So when you use Azure Storage, the basic mode is to have locally redundant storage, is the LRS. This is where the storage is, there's 3 copies of your data in the data center, and this is written synchronously. That's a very important point. When you make a call to write to the storage, it doesn't say kind of, okay, it doesn't return, that call doesn't return to you until those 3 copies are committed. When it says, okay, that's its commitment. Yes, we got that and we got it ×3. Thank you. Zone redundant storage is the same, except that now your 3 copies are spread across availability zones rather than simply being within a single zone. And then you have these geo-redundant options, and there's kind of a matrix of these. So first is your standard geo-redundant, and this is where you have 3 copies in the region you're writing to, and then asynchronously another 3 copies are written in the paired region, and the target there is to have those second 3 copies updated within 15 minutes. So that's an asynchronous copy in 15 minutes. And then there's some extra features you can bolt onto that where you have either read access to that second copy, because by default with globally redundant, the geo-redundant storage, you don't get read access to that second copy. Microsoft will flip you over to that second copy in the event of a disaster. And to be honest, there's no promise as to how quickly they will do that, because if there's because of the 15-minute data loss, if there's any possible way that they can recover the data in the original region, they will work to do that. Even if it's maybe several hours of work to get that recovery up and running, it's a huge deal to do the failover to the geo-redundant copy. So they will only do that as a last resort. They will work to get the primary site up and coming up if it's all possible. So if you do want to have your own control over that failover to the geo-redundant copy, or at least your own read access to that geo-redundant copy, then you use the RA GRS service where you have the option to read from that geo-redundant copy whenever you like. And then there's versions of both of those with a Z in them. You can see the names there, and that's where the 3 copies locally and in the geo copy are zone redundant rather than just locally redundant. So there's the matrix there. There was a question there, does this include all VM disks or just the managed disks? So when you use unmanaged disks, this stuff is very open to you there. When you use unmanaged disks, it is explicitly a blob in a storage account, and you set up the storage account, you manage the storage account. So you would choose the tier of the storage account from within this matrix. Now, of course, if you're using premium storage, which is the SSD backed, then you're only going to be on the locally redundant or maybe zone redundant, but you're within one region. The globally redundant, the geo-redundant is only available on the standard HDD tier for unmanaged disks, but I expect everyone should be on managed disks. With managed disks, this is all taken care of for you, and it's always locally or zone redundant. Managed disks do not use the geo-redundant storage. They're always locally or zone redundant. That doesn't matter if you're on standard or premium, whatever it is. If you want geo-redundant storage, if you want a copy in a different Azure region with managed disks, well, that's where what we're going to talk about next, the Azure Backup and Azure Site Recovery come in. So managed disks are always in region only. Sometimes I get asked a question, sure, Microsoft has their own backups, don't they? So if something went really pear-shaped, they'd recover from their own backups. And the answer is no. There's too much data for them to do that. If you want extra redundancy, You get what you see here. When they say they make 3 copies, they make 3 copies. But don't think there's some additional backup tapes as well, because there's not. It's just those 3 copies. Now, it's a very highly available system. There's all kinds of proactive maintenance that goes on. Those 3 copies are continually monitored. From time to time, that these background jobs will go around and check that the 3 copies are in sync. If there's a problem somewhere, maybe I don't know, a neutrino from space has hit the drive and flipped a bit, then it will actually throw away that 3rd copy and rebuild it from the other 2. It's all kinds of proactive stuff is going on in the background. It's a very reliable system, but it is what they tell you it is, and there's no kind of hidden extra backups that you can be betting on in the background. It's this and exactly what they say. Okay. Let's. Did that answer the question? Sorry, there was a question there on the VM disks and managed disks. Did that answer the question? Okay, super. Let's have just a brief look at this on the availability sets and the availability zones. I'm going to flip over here to the Azure portal. Okay, let's just refresh the portal. And I'm not going to go super deep here on this demo because many of you would have seen this before. I just want to point out a couple of features. If I go into virtual machines and I say I'm going to create a virtual machine, let's just briefly look at the settings we have here. We'll do some longer demos later, but for this is fairly lightweight. So let's keep this fairly straightforward. Suppose I'm going to choose North Europe. That's the one that's closest to me. And here you see availability options. This is where you get to choose my availability zones or my availability sets. So if I'm in availability zones, I'm going to choose zone 1, 2, or 3 for my VM. And here, if I'm going to have a public IP address, this has an impact on the networking. Whilst I still have access to my networking features, if I want to use availability zones, then I'm going to have to use a standard tier public IP address. And also, if I want to use a load balancer, it'll have to be a standard tier load balancer. Availability zones push your networking to the standard tier. That is that. So you'll see that come through if I look over on the networking tab, the public IP address that it will create. If I want to create one, it'll push me. Oh, I need to fill in the other details first, of course. Let me just say that's in the test resource group and give it a name. And we'll see now if I look at the networking tab, you can see the public IP. Okay, it's taken the name there. And if I say I want to create a new one, it's going to be at the standard tier. See, it's read only here. It's locked that to the standard tier. That's because I'm using availability zones. I can only use the standard tier. The same would be true for a load balancer. And here it's using zone 1 for the public IP, which was the same zone as my VM. Or I do have the option to have a zone redundant IP. These are typically more used when you have a load balancer that's migrating, that's load balancing across multiple zones. But you do have the choice. Okay, so that's the availability zones. If I go back to the basics, I go with the availability set option. Then you have to specify the availability set resource. Now you may have one already, or you can just create one. You can create it here, but as I say, this is a one-time opportunity. If you don't create your availability set and assign it to your VM at VM creation, that's it. The ship sails. The other thing you'll notice is the availability set. When you deploy your VM, it typically then ties your VM to that cluster or that data center. And it may be that limits what type of VM you can put in your availability set. So typically you'll want to make sure your availability set contains similar or identical VMs. You wouldn't want to, don't expect to be able to mix wildly different VM types, a G series and an N series and an M series all together in one availability set. They're often tied to VMs within a particular family or set of families. So just be aware of that. But typically isn't a constraint that causes any difficulty. Okay, so there's your availability zone and availability set settings. They're straightforward enough. Okay. There's some couple of questions on the chat there. Let me just check on those. Are there any levels of disk sync? How frequent a disk will get synced? So the disks, managed disks, you should just think of them as a resource. They are, a black box that represents a disk. Awesome. And under the hood, it's all using Azure storage, and there's 3 copies of the data, and the data doesn't get written. When you have a managed disk, the data doesn't get written to a single physical disk within Azure Storage, or even 3 disks when we talk about there being 3 copies. Actually, that data, it's kind of like you think about the blocks on your disk. That data is scattered across thousands of what internally Azure Storage calls extents, but you don't see those, but just lumps of data that is scattered across your storage cluster. And a cluster, think of a cluster as like 20 racks of servers, you know, so your disk is actually lots of little bits of data that are scattered across the storage cluster. So when it writes data, you know, it's writing what you see as a disk, and that's set into different, you know, blocks and so on. But in fact, this data is being scattered across the storage cluster. So that means you know, with normal storage, you sometimes have to think about, oh, I'm going to do RAID striping or something in order to get better performance. Well, in this case, there's no point. You know, the disks, because the data is being spread out across the storage cluster, you already get that RAID-like performance and that RAID-like redundancy. You know, there's 3 copies, all the rest of it. It's all built into the disks. So where in a traditional IT world, you would think that just running my VM on a single disk, you'd think that's kind of crazy, right? Because, you know, I need a reliable disk. What happens when the disk fails? You should recognize that a managed disk in Azure is not a single physical disk or even 3 physical disks. It's a highly available representation of a disk. So don't bother with adding your own RAID on top or anything like that. It doesn't make any sense. In case of disk sync, I'm not quite sure what you mean on the question there. There is a option with disks whether they have a local cache or not, because as I say, the disk is on the storage cluster. Your VM is in the compute cluster, and okay, on the SQL side, yes. So your disks are over the network, effectively, the data center network from your VM. But there is an option to have disks that are local to your VM. The temp disk is local to your VM. There is a feature with Azure called ephemeral disks, which is where you have a disk that's local to your VM, but if the VM has to reboot, it's going to lose all those changes and you're going to just go back to the standard image again. And the other thing is there's an option to have caching, write caching on the disk, so that you can choose when you set up your disk whether it has a local cache local to the host. So if you have caching off, then all of your disk writes are committed directly back to the storage cluster, whereas 3 copies committed to the physical disks. So if you're concerned about writes and losing information in a crash, then make sure you have caching disabled. And then, like I say, you'll be writing everything straight back to the actual 3 copies on the physical disks in the storage cluster. Alternatively, you can have the caching turned on, and then of course you get better performance, but you get the you know, the slight risk in the case of an outage. Microsoft, for their own workloads that you might be running in your VMs, actually provides guidance as to whether your caching should be on or off. You know, you can look in the Azure documentation and you can see guidance on whether to have disk caching enabled. Should you have it on your OS disk? Should you have it on your, I don't know, your SQL disk, your, you know, whatever it is. So you can get guidance on whether to have the caching. So the question was there, will there be data loss when the primary disk gets a crash? So if you have caching off, then as I say, everything is written back to storage where it is spread across the storage cluster, and that's the strongest story there. Hopefully that answers the question. Yeah, and the question there on storage spaces. So yes, you can use storage spaces within the VM to increase the disk speed. It is done. And you know, if you're running multiple data disks, just be aware. The reason I mentioned the 3 layers and the way this data is spread out in the data center is you do see people using the disks, you know, following the traditional IT tools for reasons that they don't need to, where they're adding multiple redundancy, you know, RAID redundancy on top of Azure's redundancy, which you really don't need to do. But yes, you can use things like storage spaces to increase the speed. There are different disk performance tiers, and you can certainly, by using things like storage spaces, get better performance. But do be aware when you think about disk performance that the disk has performance limits, IOPS limits, throughputs limits, and those are tied to the size of the disk. The Azure documentation will have guidance for you to say, look, for this size of disk, these are the performance limits, and you know, they're tied to the size of the disk. But in addition, the VM also has disk performance limits that are tied to the family and the size of the VM. So there's no point having a super fast disk and thinking it's going to work super fast if it's on one of the smaller VMs, because in that case, as you get a bigger VM, you also get more disk IOPS, more disk throughput. So if you might be hitting the VM throttle limits on disk access rather than the disk limits. So both limits apply, disk limits and VM limits. So do think about both of those when you are sizing your system and choosing your storage. So it's on both levels, disk and VM. Okay, we digress a little bit because we're supposed to be focusing on availability here rather than performance. But hey, these questions are all good. So we're happy to digress a little as we go along. We'll just have to keep an eye on the time. Okay, so the other thing, just the last one, there is this service called Ultra SSD disks. These are only very much preview in a couple of regions. Last time I looked, it was only one region actually, but maybe they've expanded it. But these give you amazing performance. They're like, you know, having multiple disks that are all set up in storage spaces and striped for performance and so on. And that is an awesome service. And there you kind of size your disk and the throughput of the disk independently, but they can be expensive. If you set up a super high IOPS, super high throughput disk with ultra disks, it could be pricey. But anyway, we digress. As I say, let's keep going. The next area, we can have more time for Q&A at the end, and we have 2 hours booked, but I'm happy to run over. If there's more Q&A, hey, we just run over. That's okay. Okay, let's talk about Azure Backup. As we said, with managed disks, all your data is in one region. So you will want to think about backup. You want to think about, okay, well, where is my data being backed up to? So let's have a look at this backup story. Okay, so Azure Backup is an Azure service, and it supports a wide range of, it's all about backup, right? And it's all about backup. It's very much a hybrid service. It's backup for on-premises environments as well as backup for your Azure stuff. And it's interesting actually, because if you look at the history of the service, it actually supported the on-premise backup scenarios first, and Azure Backup came later. So it's very much designed as a hybrid scenario. And cloud is a great story for backup. You know, cloud is great at this. You know, the whole storing the data, storing it in a sufficiently far away location. It's the kind of thing that's really hard to do without the cloud. You know, tons of cost of doing this outside the cloud. But with cloud, you know, it's a great story. So let's go through some of the features here. I'm not going to talk too much about the on-premises scenario. I think this is the only slide I have on the on-premises scenario, because I am going to focus on the Azure scenario for Azure Backup. You know, the focus of this expert talk being all around availability and resilience for your Azure applications. But just for completeness, be aware that Azure Backup does have a comprehensive story for your on-premises scenarios. That can work either with an agent that you install on the machines, or using something called an Azure Backup server, or using System Center Data Protection Manager. So there's various options there that can integrate this. Setting it up is really nice. If you're in 2019 and you have a Windows Admin Center, you can set it up through Windows Admin Center. It's a nice hybrid scenario there. Backup server and System Center, they have the advantage compared to the just using the single agent-based approach of just some more orchestration and better compression and so on for the you know, the bandwidth management side of things. But these are the scenarios. They all work pretty well for the on-premises scenario, and that's all talking up to Azure, to the Azure Backup service, which runs in this resource type called a Recovery Services Vault. So that Recovery Services Vault is used for both Azure Backup and Azure Site Recovery, and we'll be talking about that much more as we go along. Okay, so there's your backup scenario there from premises. Now in Azure, if you're running your workload in Azure, there's a few other things that are supported with Azure Backup. So you have the ability to do backup of your Azure VMs, Windows or Linux, and that's natively kind of plumbed into the wiring of Azure. So it doesn't require you know, any kind of backup server or special network access and so on. It just works. There's also, if you're running SQL on your VMs and also now SAP HANA on your VMs, those databases can be backed up natively into Azure. And compared to normal SQL backup, that's a big advantage, because again, you don't need any special backup servers. You know, it's kind of integrated into the platform. So that's a very lightweight, no infrastructure way of doing your SQL backups. And of course, these are native SQL backups. They're not just, hey, we're backed up the disk. You know, it's proper SQL integrated backups that we're doing there. Now, if you're using the Azure Files service, which is I really love Azure Files, you know, for Azure Files shares, then there is a backup facility for Azure Files as well, but that's still in preview. There's a question there. I'll come to the question in a moment. So let me just park the question for a sec, but just acknowledge that I've seen it. I'll come to the question in a second. So Azure Files has a backup, but this is a little different. With the other backups we talked about, your actual data, the backup, goes into your recovery services vault. Now, and Azure Backup, in using the recovery services vault, is actually going to store this in a storage account, but you don't see the storage account. You know, it's managed for you, but it's all going into Azure Storage with the 3 copies and the geo-redundant that we talked about, and we'll come to that more in a moment. Azure Files Backup, well, Azure Files is already in Azure Storage, right? Azure Files is an Azure Storage service. So Azure Backup does not copy the Azure Files and put them into its own storage account. Azure Backup simply coordinates taking snapshots within your storage account. So this one is in your storage account. And you can see the snapshots. They're not hidden away in the Azure Backup service in the Azure Backup storage account. So one important thing to think about here is geo-redundancy. So your VMs, they're using managed disks, and that means that they are single region. They might be using availability zones, but they're still single region. So for your VMs and your backup, the recovery services vault for backup must be in the same region. Bizarre, huh? People look at me and they, are you sure? Yes, for backup, not for site recovery, but for backup, that vault is in the same region. However, the storage account used by the vault, which is also in the same region, can have geo-redundancy turned on. The geo-redundant storage we mentioned, the geo-replication can be turned on. So an important part of setting up Azure Backup is to make sure that the recovery services vault is using geo-redundant storage, because that will replicate your data out of region, and that's how you're protected against the region having some massive catastrophe and data centers burning to the ground. So make sure you've got geo-redundant storage turned on your recovery services vault. That is on by default when you create a vault. It didn't used to be, but it is now the default when you create a vault. Once you start creating backups, you can't change that setting because a storage account exists and that's it. So that's a setting. When you create the vault, you can tweak that setting, but the moment you start backing stuff up, that ship sails and you can't change that setting anymore. So that is that. So your VMs, the way you back up is that you back up to the vault, which is in the same region, but that is using geo-redundant storage, which gets you into another region. But access to that second region is all through the backup vault. It only happens in the event of a disaster. You don't have any way of verifying that and doing a recovery from the remote backup for yourself. You can do recoveries, but you don't get to control where it came from, which copy of the data. But as I say, Azure Files is different. Azure Backup is simply coordinating snapshots within your storage account. So if you have Azure Files and that is locally redundant, then even if your vault is using geo-redundant storage, you don't have a geo-redundant backup because the backup is in your storage account, which is locally redundant. So Azure Files is a different story there completely. There is a facility to replicate your files to a different region. There's a thing called Azure File Sync, which can replicate your files to a different region. And there you could then set up backups within that other region. So that would be the way I'd recommend doing that. So the replication isn't creating backups, it's just synchronizing the data across 2 different regions. But you can use Azure File Sync to set the replication across 2 regions, and then you can create backup in the remote region from the Azure File Sync version. So that is the way to set up Azure Backup for Azure Files in a remote region. Okay, and then the question was, can we spin up the new VM from the VM backup copy? So yes, you can, and we'll talk about, I have a few slides on the recovery story coming later, so we'll answer this. This will get answered as we go. You'll see the details on that. Okay, so this is how the backup works. The backup is taken by taking a snapshot of the VM, and if the VM is running, that is done with the snapshot extension, which gets installed on the VM just during the backup and then taken away again afterwards. So you don't see the extension if you're not actually taking a backup at that point in time. If the VM's not running, it doesn't have to get started up to take the backup. Instead, the platform just takes a backup by just copying the disk, and that, of course, doesn't need the extension. But that's a different type of backup, and we'll talk about that in a second. So the snapshot gets taken, and then that's fairly quick. And then asynchronously, that gets uploaded to the recovery services vault. Now that could take some time, minutes or even hours. You might be backing up hundreds of VMs, and it's important in those cases, if you have lots of VMs that are synchronizing up to that vault, what you need to do is you need to stagger the times. You have something called a backup policy that says, okay, do these VMs at midnight and do these ones at 1 o'clock and these ones at 2 o'clock and 3 o'clock and whatever it is. And you should, if you're doing lots of backups, you need to stagger those across the clock, because they otherwise you'll get throttled on the storage side when you're trying to upload all of this data. So that's a good. We'll talk more about best practices at the end of this deck, but you'll see that there as spreading out things across the clock. Okay, so there's your data up into the recovery vault. If you need to do a restore, those VM snapshots that you took are retained for, it's configurable, but typically 2 days. And if you're doing a restore from one of those recent backups, you can get it off that snapshot. So that's a fairly quick process. It goes to a staging blob, and you have to specify this staging storage account, and then from there the VM is restored. And alternatively, if it's not one of your recent backups that you're choosing as the restore point, then of course the data has to come out of the vault, and that is slower. But it all works. So that is the story there. There was a question there: is the best practice of Azure Backup to do a single backup daily? So you configure this thing. We'll see in a little while that there's a thing called a backup policy, which controls how frequently backups are taken and also what the retention is. So let's just park that until we get to one of the slides coming up soon, which has a screenshot of the Azure policy for that, the backup policy. Okay, so when it takes a backup, there's different types of backups in terms of the consistency. And if we're talking about the kind of the operating system consistency, is this backup a scrambled version of my disk, is what the question we're trying to answer. So Windows has this thing called the volume shadow copy service, which is a service in Azure which various applications that run on Windows use, including things like SQL or Active Directory. And it enables those applications to make sure that their backups are consistent. If they're busy writing across multiple tables or files or whatever it is, it just enables the backup service, this shadow copy service, to take a snapshot that is that the application is not in any kind of corrupted state. And Azure Backup uses this, and that's why it has that extension, of course, that plugs into the VM. So this ensures that the application is in a fully consistent state. These are these backups are, should just fire up smoothly with no issues whatsoever. On Linux, there's no such service, but there is still the option to create application consistent backups, and that's done by you configuring your own pre-backup and post-backup scripts that will run. So the service will run these scripts for you, and if the scripts both return true, that both return success, then the backup will be marked as application consistent. But it's your responsibility that when the scripts return success, that it means something. If you want to create scripts that return success having done nothing, hey, your funeral, right? So you're responsible for the correctness of those scripts. If the scripts fail or the shadow copy service returns an error, then you get what's called a file system consistent backup. So it's just consistent at the file system level, but the application, if it was in the middle of multiple changes, may not be in a consistent state, and the application may need to fix up the data. And then the last one is, if none of that works, then it will just, at the pure disk level, it will just take a snapshot of the disk. And this typically will boot okay, but it's like you've just pulled the plug on the VM and it's just a hard dump of the disk. So it might, if this happened when the machine was running, then you may need to run disk checks. But typically you get these crash consistent backups. You see those in your logs, and they simply indicate that the backup was taken when the VM was shut down, and that's that's what that means. Okay. So limitations, we talked about the region limits already. So your backup and restore in the same region, but you can use globally redundant storage. There's at most 16 data disks per VM, and you're allowed up to 32 terabytes per disk and 256 terabytes total. These numbers keep changing, so they have increased these in the last year or so. So the question there was, do we need to do any settings before taking the backup to avoid shutting down or downtime? So the answer is no. I mean, on Linux, if there's something special with those scripts, you can integrate it with those scripts I mentioned. But no, the backup can be done just while your machine is running. That's all fine. So it won't back up network drives. If you've got network attached storage, it won't. Again, if it's Azure Files, which it should be, then of course you can just use the Azure Files backup we mentioned. It doesn't back up the temporary drive. There's a feature in Azure called the write accelerator that doesn't, that's not supported, so you can't use that with Azure Backup. And there's no consistency model for multi-VM consistency. That is supported on Azure Site Recovery, we'll talk about later, but not on Azure Backup. So if you have some application that's using cluster shared volumes, scale out file service, things that are scaled out across, with a consistency model across multiple VMs, that's not supported. You can back them up as individual machines, but you can't back up with multi-VM consistency. Although it does do consistency across multiple disks within a VM, so that works fine. Okay, so set this up. You start by creating the vault, and then, as I say, before anything else, check the geo application setting and also check the soft delete setting. Soft delete is a feature in Azure Backup where even if you delete the backup data, it's not deleted. It's kind of marked as deleted, but it's actually recoverable for 14 days, and it's actually only hard deleted 14 days later. So your vault is actually, you're actually stuck with the vault for 14 days as well. But you can turn that setting on and off. So that means when you delete the data, you still have it, and you can recover the soft deleted data and then do a recovery from it. So they've done a lot of work to make sure you don't delete backups by accident, or if you do, you can get them back again. If your VM needs to have the VM agent installed. If you've just done a migration from an on-premise machine that didn't come from the Azure Marketplace, you'll need to install it. But to be honest, your VM will have this anyway, so you can ignore 0.4 and 0.5 as well. Any Linux machine from the Marketplace has Python 2.7 or higher already, so you can don't worry about 0.4 and 5 too much. Okay, and then having set up your vaults, you then want to set up the VM, and you can do this from the VM blade. We'll look at a demo in a moment, and you can also do it from the vault. And the advantage of doing it from the vault is you can do this at scale. You can multi-select lots of VMs rather than doing it one VM at a time. Actually, my personal preference is, rather than doing it in either of those ways, is you can do it using Azure Policy. You can use Policy to automatically back up any VMs you create in a certain region or whatever scope you set the policy over. So you can do automatic backup of all your VMs using Policy, and we will have a look at that in a short while. So here on the right-hand side, you see the backup policy, and here you give the backup policy defines when the backups are taken and how long they're kept for. So you can see you set up your backup frequency, and here I think for Azure VM backup it supports daily backups. For some of the other types it talks about, like the on-premise backups, I think in some cases it supports twice a day. This is one of the things with across all those different backup types, it varies how frequently it will do the backups for you. You can also do an on-demand backup where you just click the backup now button, and that's separate from the ones defined by the policy. So you say, okay, it's going to be a daily backup and what time it's going to run at. And you then choose how long these are retained for. So you say, okay, keep my daily backups for a month, and I'm also going to keep weekly backups, monthly backups, and yearly backups. So you say, look, my weekly backup is my Sunday backup, and I'm going to keep that for 12 weeks. And then I'm going to say my monthly backup, is it one of my day-based or week-based ones? I don't know. And this is going to be my day-based backup that I'm going to take the day number 1, the first day of each month, and keep that for 60 months, 5 years. And then a yearly backup, similarly, you can say, okay, January the 1st backup I'm going to keep for 10 years or whatever it is. So these are your retention policies and your backup policies. So that's in this thing called the backup policy. So with that all in place, the backup will be configured, and you can see there it has a warning, initial backup pending. So you can just ignore that warning. When the daily backup comes round, it will back it up, or you can click the backup now button if you're really nervous and you want to back up immediately, and that will just work. It will run away and it will do the backup at that time. To check the status of the backup, you have this thing called backup jobs. I mean, anything in Azure Site Recovery, it has a lot of these background jobs, and you can review all those jobs there. Not just taking backups, but also configuring backups, restoring from backup, all those things. So this is I see there was a question that you got the answer for. Okay, great, fantastic, thank you. So there's the backup jobs. That's the way you check that everything is working correctly. We'll talk more about monitoring Azure Backup later, but you can check here the status of each task that Azure Backup is executing in the backup jobs. So that's great. And encrypted VMs are supported. If you set up the encryption first, everything will just work. But if you have set up the backup first and then you enable encryption, then what you will need to do is when you set up the encryption for disks, this is using dmcrypt on Linux and BitLocker on Windows. And what you will need to do is your keys will be in Azure Key Vault. There's a couple of different modes, a couple of different options for that, but they both work. But your keys with Azure Disk Encryption are in Key Vault. And what you will need to do is to grant a Key Vault access policy to that key. So you'll find the key that's in Key Vault, and you can see on the screenshot there, it's you set this. There's a template for the access policy, and this is the Azure Backup template that you can use, and this gives the appropriate permissions, and you need to grant those permissions to the Azure Backup service for it to work. It doesn't actually use the keys to decrypt your data and store clear text data or anything crazy like that, but it just needs access to those keys. There's the permissions it sets there for you, and there's a little call out there that you can actually fine tune those in certain cases. But just bear in mind, if you're setting up for encrypted disks, you may need to set the Key Vault, make sure the Key Vault has access to the grants this access policy for the backup service. So that is that. Let's have a look at it in practice. Going back to our options here. So I should have an existing virtual machine that doesn't have backup. Fingers crossed, I've got this all set up. If I look at my VMs, okay, you can see I have a whole bunch of VMs here. Let me look at this one. I don't think this one has backup enabled already. This one is in North Europe, and I do have a vault already in North Europe. Oh, it's quite slow. Okay, so here we see the VM, and within the VM, to do just right here, backup, you just go to the backup settings, and here you can configure backup for an individual. Now, this one does have backup set up. You can see I have the initial backup pending. I can click backup now. Let's see if I have one that doesn't have backup set up already. Let's just check. Okay, here we are. So this is where you can say, okay, use a new recovery service vault, or you can select an existing one. I have here the vault. It has to be in the same region. This one is West Europe, and I can choose which backup policy within that vault I want to use. We saw the policies just now, how frequency, and it just gives me a summary here of what that policy says, and I can just click enable backup, and that will do it. So that will create the job that sets up that backup for me. I won't do it right now, but you get the idea. So when I have a VM that's already backed up, configured for backup, I can just click the backup now to create a backup. How long do I want to retain it for? Okay, that's just going to do the on-demand backup. You see, I have to specify the retention there because the backup policy only applies to backups that are created by the policy. So I specify the retention individually on on-demand backups. Let's go and have a look at the vault. Creating a vault is trivial. You just go in and you create the vault. It's super easy. Let me just show you that. The way you find it is actually it's one of the interesting ones. If you start searching for recovery services vault over here, you probably don't find it. Yeah, backup and site recovery is what it's under. If you start searching for recovery services vault, it says not found. But that's what it's called. I normally go, if you go to IT and management tools, there it is, backup and site recovery. That's the one you want. So here it's a very simple resource. You give it the vault a name and you specify the region and you give it a resource group. That's it. So there's nothing fancy at this stage. So I'm going to skip over that. I've got some that I've created, and it's quite quick to create as well. So, but I do have some created already. If I go to my vault resource group, in here I have a vault. Let me have a look at this one. This is my West Europe vault. And in here you can see the various settings. If I go to the properties tab, this has these various settings hidden in these links. Yeah, these links actually, a lot of the configuration at the vault level is in these settings. The ones at the bottom are more to do with on-premise. I'm going to skip over those. But here, this configuration, this is where you set the locally redundant. And you see, this is I'm committed now to locally redundant because I changed it and then I created some backups. You have to do this first thing before you create any backups. And then in the security settings here, this is where you can have that soft delete control, whether you want soft delete enabled or not. I've got it disabled simply because having it disabled makes it much easier for me to clean up my vaults when I finished all my demos. But in practice, for a production environment, you would have that enabled. And then there's some other settings again to do with the on-premises scenarios. So I'll ignore those. Okay, fantastic. So there's where your settings are hiding under their properties. Now to actually back up the items, you can see under backup items, I can review what my currently backed up stuff is. And it comes in these different categories: VMs, file storage, and then you can see the other scenarios we talked about: SAP, SQL, data protection manager, backup server, backup agent. So here I can go into my virtual machines, and you can see here the various virtual machines that I have backed up. And I can add more virtual machines from this point here. Although if you want to add virtual machines from the vault, the easier way to do it is under this getting started item on the left, because here it's like a wizard that you just walk through. You say, okay, where is it running? It's running in Azure. What is it? It's a virtual machine, back up, and it just walks you through the wizard. So you choose your policy, choose the items, and here you can select multiple virtual machines if you like to. They're all backed up already, so there's no options for me. But you get the idea. You just walk through this wizard, and that's the way you can set this up most easily. And the same for site recovery. Use the wizards that are under here, certainly while you're learning. But then to tweak existing stuff, you'll find it under here. And then there's a few other settings here, like the backup policy that we mentioned. You can see here I have a few backup policies. Here's the backup policy. Now the backup policies have a type. You see here, this is a virtual machine type 1, and there's other ones for file shares and so on. But here's my backup policy with those settings that we talked about. I can modify this if need be, and those are the things we just saw on the screenshot, when these are taken and how the retention. So daily or weekly is the options for Azure VMs. Okay, enough. So that's how we set up the backup. We're going to look at restore separately. Let me talk through the slides on restore first. So let me just get out of here. Okay, so let's look at restore. So there's a few options for restoring, and let's run through them. So the first one is you want to create a new VM. So this will just create the disks, create a brand new VM for you. Awesome. So you just go and say, okay, back up, restore the VM, please. Choose a restore point, and you will it'll create the VM for you and the disk and everything up and running for you. You have to specify a storage account, and the portal doesn't let you create a storage account at that point in the workflow. So you need to create a storage account in advance. Now, what is that storage account? It's kind of a staging location that's used to host data during the recovery process. And even if you're on managed disks, you still need the storage account. So you have to set up that staging storage account. And there's a few restrictions on that. It has to be in the same region. It shouldn't use ZRS, and it should be a standard tier account. So do set up that storage account in advance, and you have a couple of options here. You can create a new VM, which obviously will have to have a different name to your existing VM, unless you've deleted the existing one, in which case you can use the same name. Or you can replace the existing disk on your existing VM. That's a relatively new feature they added. So you can say, look, okay, this VM's scrambled. I like everything about the VM, but just replace the disk. Just yank out the disk, put a new disk in for me. And this all works, so your basic scenario for a basic VM, you can just restore the VM like this, easy peasy. The next option is to restore a VM via what's called a disk restore, where Azure Backup will just create the disk for you, nothing else. And then you then manually go and create a VM that uses that disk or those disks yourself. Now, this is useful because the restore VM scenario I just talked about has a few limitations. And with this one, you work around all those limitations. Here, for example, if you have a VM with multiple NICs or multiple public IP addresses, or if your VM is assigned to an availability zone, or I think availability sets now, I think the slide is inaccurate there. I think availability sets are now preserved on the restore VM. But if you want to use availability zones, let me just check the slide. I'm wrong. Availability zones are preserved on the restore, but not availability sets. So if you want to assign the VM to an availability set, if you need to put the VM behind a load balancer, if you have used disk encryption in any of those scenarios, and let's face it, if it's a production VM, then one of these is going to be true. I mean, it's as simple as that. It is. So in pretty much any real world scenario, this is the world you're going to be in, where you do a disk restore and then you rebuild the VM. Also, if you're using command line tools, there's no such thing as the VM restore. You have to do a disk restore and then you build the VM from the disk. So that is your standard approach. The backup job also gives you a template you can use to create the VM from the disk. You probably want to edit the template, but it's a starting point. Otherwise, you just create the VM using CLI or PowerShell. So that's the disk restore approach, which is probably your most standard approach for real backup disasters. And the other one, and someone did ask about this on the thread, thank you for that. There is an option to restore individual files, and the way this works is that you maybe there's just one or two files you want to get off that particular backup. So what you can do is you can mount the backup as a disk effectively on your machine. Now, typically I wouldn't do this on your local machine. You probably just spin up a clean VM and mount the backup there. So what happens is you get an executable, kind of a script that you will run on your machine that will mount the backup as a drive. And as a security thing, there's a password you can see on the screenshot. There's a password that you are given in the portal, which you will then be prompted for by that script, and you'll paste that password into the script. And then that will mount the drive on your, for that particular backup on your, whatever machine you ran the script on. Typically, as I say, do it on a clean VM. And you can then copy files over. Now, there's some limits there. You only get to access for 12 hours, and it's 1 GB an hour. So they don't want you using this approach for any large amounts of data. But for small files, small volumes, you can use this. And it's probably quicker to do this than it is to use the full backup that we talked about previously. And when you're done, there's a little button in the portal you can click to unmount the disk again. So that is how that works. I hope that answers the question. We could do a demo. I'm just a little concerned for time because we still have a ton of stuff to cover. So I'm a little concerned for time. So I'm going to skip on the demo, but I'm happy to do a demo at the end. As I said, we can run over on time, and we could do a demo at the end if that's still valuable for whoever is those one person asking for that. So we can do a demo at the end for that if the slide isn't enough. Okay, so that's the file restore. After you've done the restore, in particular, if you've done a disk restore or you've done a VM restore, there's still a few things you might need to fix up. So in some Linux distros, you will need to reset the password. VM extensions may be disabled and you might have to reinstall them. If your VM had a static IP, it's probably going to be restored with a dynamic IP just to avoid IP conflicts. So you'll have to fix that up. And the VM itself, the restored one, may have Azure Site Recovery or may have Azure Backup running on it, and those get disabled. So you may have to go in and re-enable Azure Backup or Azure Site Recovery on the restored machine. So there's a few things that you'll want to go and just fix up and check at the end of this, once the VM is up and running. So don't forget to do your housekeeping there. So we'll just look briefly at the restore options here in the portal. Here we go. So if I look at my VMs, I'm here in my vault. I go to a particular VM. Let's say this one. And you can see I have some backups that I've taken here, crash consistent because the machine wasn't running. If I look at let me look at this one instead. I think this one has a mix. Yeah, there we go. This has it was shut down for that backup, but running for the others. So here we go. So this one here, you can say, okay, I want to restore the VM or do the file recovery here. If I do restore VM, here you get to choose, well, what's my restore point, first of all? Typically you'll take the most recent, but maybe it's a data corruption issue and I'm going to take an older one, whichever. Choose your restore point. And you then choose, am I going to create a new machine? In which case, am I going to create create a brand new machine with it, which obviously have to have a new name, or do I want to just restore the disk only and then create a new machine from that disk myself manually afterwards? Or I can do the replace existing disk, which says, okay, I know what machine it is. It's the machine you've already got, and we're just going to replace the disk. But in both cases, you see, I have to choose a storage account that's going to be used as the staging location. So if I'm going to create a new virtual machine, let's call it recovered, and we'll just put it in that resource group, give the VNet and the staging storage, and we can let that go. Now, I'm going to fire this off. It takes a little while. We may come back to look at it towards the end of the session. Now, I'll give a warning, it might fail, and that's simply because I have a ton of other VMs running in that region, and I have a horrible feeling I'm going to hit the 20 core limit. I haven't done a count, but I must be getting close to it. But anyway, fingers crossed. Let's fire that off. And now here, okay, restore, boom. So that will go and restore that machine. We're going to make a new machine from the backup. So so that's triggering the process. And let's just show you how you monitor the progress on that. Okay, that worked. So if I go back to my Vault, and if you see here, I've got my backup jobs. Where are they? There we are. Backup jobs, just me being blind. There we go. Backup jobs. Here's all the different stuff. There's my current, my restore, and that's in progress. And if I drill in on this, you can see the other one that I did before. There's a restore I did earlier. There's a backup here that that completed. If I click on this, and you see here the restore is in progress, and you can see here there's subtasks within the job, and you can monitor the progress on there. So transfer data from Vault in progress, and the next one is create the restored virtual machine, and so on. So here's the progress of the thing, and you can cancel the job as well if you want to. So you can see here this is chugging away. I think I chose one of the older restore points, which also make this slow as well. Anyway, you get the idea. It just works. Okay, so let's keep going. Backup at scale. You know, it's easy to look at these pointy clicky demos and think, okay, that's great, but now let's get into the real world. You have a lot of machines. You might be running hundreds or even thousands of machines. Let's get serious about how we do this at some kind of scale. So there's an Azure policy available. There's built-in policies that Azure has given you, which help you use Azure policy to automatically configure backup. Now, this is Azure policy. This is not the backup policies we talked about that say how long you're going to keep your backups for. This is Azure policy, which is your kind of governance layer in Azure. So there's a policy to force backup to be enabled, and you can also use that to remediate existing VMs and turn on backup on existing VMs. And there's also another policy you can use just to do compliance reporting to see that, you know, across your regions the backup is in place. Why is that useful? The reason is the one that enables the backup, one that enforces backup, that policy has to be assigned per region. So that's a separate policy assignment for each region, which means you don't get a compliance report from that first policy that's an all-up view across all of your regions. Whereas the second policy, because it's not trying to enforce anything, it can actually cover all of your regions and give you an all-up compliance report. So that's where the second one is useful. There's also a service, a very new one. This is actually only announced as preview in February, which is a Backup Explorer. And this is always there. It's a zero cost, zero setup workbook that is just giving you a very quick dashboard of your current backup status. Gives you a 7-day history, and it just updates straight away. It's up to date all the time. It's awesome. You know, this just but it only covers your Azure VMs. It doesn't cover all of your other backup scenarios like your on-premise and your file shares and all that stuff. This is just your Azure VMs. But they do say it's in preview, and they hope to add other types in future. This is a kind of example of the view. You can see your jobs, and then there's some tabs here. You can see backup items, jobs, alerts that you can drill into for more detail. We'll look at demo in a moment. So this just lets you understand how your backups are doing, and gives you a single pane of glass. And in particular, you can use this report across multiple recovery service vaults. We can cover all your regions. You can even use it across multiple subscriptions. And if you're a partner managing backup as a service on behalf of your customers, you can even do a single pane of glass across multiple Azure AD tenants using Azure Lighthouse. So you can really do this as a single pane of glass. They're really, really good from that point of view. There's another one. This is another preview. This was announced on the 4th of March, which is a thing called Backup Reports, which is a similar thing in that it's an Azure Monitor workbook that gives you this overall single pane of glass view of your data. But the difference here is that this one goes into more depth. This one, it's much slower. So it requires integration to a log analytics workspace from your Azure Backup diagnostic data, and it takes at least 24 hours for the data to really show. But this one is covering all those different services, you know, SAP and on-premise and file shares and all that stuff. So it's covering everything, and it's giving you more of a deep view on how much storage are you consuming, for example. Lets you think about your storage consumption trends, identify where the costs are coming from in terms of, you know, which backups are driving your storage costs. Lets you look at, you know, how many VMs do you have on each of your backup policies, because if you have too many VMs on the same backup policy, then of course you're gonna have a lot of VMs backing up at the same time, and that's gonna impact performance and so on. So you can look at those trends, okay, how many backups do I have on each policy? and so on. So you can use this much more as a tool to make sure that you're configured in a healthy way and to look at longer term trends of how your backups are working. Setting this up requires a log analytics workspace to be configured for your vault. So that's fairly straightforward to configure the workspace, but even better, there's a policy that can do it for you. So you can deploy this diagnostics policy. The moment you set up your vault, you can just say, okay, and here's a policy, and then you can, or rather, the moment you set up your log analytics workspace, you deploy this policy, and then all of your recovery services vaults will automatically be configured to use this workspace for their backup data. So then that's just done for you. You don't have to set up the vaults individually. Again, thinking of the multi-region scenario. So here's some of those scenarios. Storage consumption, you can see some trends there. You can see job status, and it helps you identify if failing jobs, and that you dig into what my most common causes of failing jobs and so on. You can look at a backup storage consumption by policy and so on listed there, and you can see this dashboard of what is going on across your backup estate. And again, this is a single pane of glass across all your vaults, across all of your subscriptions and so on. So this helps you manage backup at scale. Let's have a quick look at it. Very easy to access. So you simply, in your vault, I wonder how this is doing. This is still going. In your vault, you just go to the overview blade at the top, and you go to Backup Reports or Backup Explorer here. If I click Backup Explorer, this will load. And whilst I've gone in from a single vault, I use that link to launch it from that vault, but I'm not tied to that vault in terms of the view I'm looking at. I can choose multiple subscriptions here, and that, as I say, includes Azure Lighthouse to do subscriptions across other tenants. And I can choose which locations. Perhaps I've got multiple vaults per locations, or drill down to an individual vault, but I can just say, look, show me across everything. And here you can see I've got 10 backup items, 14 jobs, alerts, and so on. And I can look at the tabs at the top here to drill in. I can see, okay, well, what do I have backup items? Okay, here are my backup items. So some of them are initial backup pending and some of them are protected. I can check the health. I can look at my jobs and I can see what my jobs are. I should be able to query return no results. Let me click out, click in again. The status here is failed. Let me just look at status all. There we go. And so I can investigate failing jobs and so on. I can look at my alerts from my backups. We'll talk about those in a moment. I can look at my policies and see how many protected items are on each policy, what the retention is on each policy and so on. Just gives me an overview is that set up the way I think it is. And also identify VMs where I don't have backup enabled. Don't forget, this is limited to just VMs. So there we go. See what's what there. And then the backup reports. Now, I don't think I have enough data to actually see the backup reports, but let's cross our fingers. The backup reports I don't think will work, but let's see. Again, you just access it from the overview panel and select your workspace. Here again, you're specifying the log analytics workspace rather than the vault, notice. And here, no backup data is available yet. Okay, I don't think I have any real data. Oh, I do. It's come through. Okay, jobs created, backup. And see, this is out of date. You can see I actually have far more than that because this data is 24 hours behind. It doesn't show you anything from the current day. It shows you from yesterday and back. So this gives me a drill in on my older data. I say use the Explorer for the current view. This is more for kind of that long-term investigation scenario. And this does, as I say, cover all the different types of backup. You can see here I've got my backup trends and so on here. 2 backup items. Okay, you get the idea. Okay, yeah. So this is really if you've been running for much longer. Okay, enough. Okay, backup alerts. You want to know when things go wrong. Backup itself in the Recovery Services Vault has a feature to do alerts by email only, and it can notify you of alerts, either an hourly digest or just when an alert happens, and you can specify is it critical or is it warning level or whatever it is. And you can also get alerts through the Azure Alert Service which of course means you have action group support, so you can get SMS messages, email, send it to various groups of people, the full workflow that comes with action groups. And those can be from the activity log, which could be things like deleting a backup vault. You might want to get an alert if someone deletes a backup vault. Or you can, if you have your vault integrated with log analytics, like we just saw is needed for the backup reports, then from that log analytics workspace, you can create log queries that drill in on particular tasks that your backup is doing. So you can create a query that dives in on the particular backup jobs, for example, and create an alert for failing jobs. So you can do that from a log analytics query and do a query-based alert. So that's the options for creating alerts there. Those who have used Azure Backup for some time may be aware that there are reports available in Power BI, and there is also those reports in Power BI are on a deprecation path. The plan is to replace all of this with log analytics and the reporting that I've just shown you. So you should plan to move away from Power BI for Azure Backup. Now, there's also a change in how the Azure Backup writes its diagnostic data. You can see on the screenshot, the ones that are ticked in blue are what's called the V2 schema. These are the ones that are enabled for the backup report that I mentioned. These are the ones that are enabled by policy for the diagnostics. There's some legacy data that goes into that table called Azure Backup Report. You can see there, that's called the V1 schema. Now, this is on a deprecation path. This is used by some legacy solutions that you can put in log analytics, but those are no longer available. If you are using the legacy V1 schema, or if you have if you're using it maybe with those legacy log analytics workspaces or solutions, or rather, or if you're using it, you have your own custom queries that are set up against it, then you should look at migrating to the V2 schema. So, because that again is on a deprecation path. They haven't published a time frame yet, but it's just, that's the direction of travel for those. So just be aware of that. Best practices, last items on Azure Backup here. Enable it using policy. I think that's a great way to enable it. Enable Backup Explorer and Backup Reports. Again, there's policy to enable the Backup Report configuration, make that easy for you. Spread out your backup times by using multiple policies, at most 100 VMs per policy. So spread out, so that you don't overload you get throttled on the upload and make your upload very slow. Schedule them in off-peak hours as well. That can also help in terms of your VMs. If you're moving a VM between subscriptions or between resource groups, you should stop the backup and re-enable afterwards. That's the best way to do that. And the other thing you may have seen is, if I just show you quickly here, if I look at my resource groups, Azure Backup creates a resource group of its own. You can see here, Azure Backup RG West Europe 1, Azure Backup RG North Europe 1. These are created by the Azure. I think you can override the name, at least maybe not by the portal, but if you do it by templates. But the name here, this contains, you have to do the show hidden types. This contains these restore point collections. These recovery points are listed out here as resources within this vault, within this resource group. You can ignore them, just don't touch this stuff, basically, is the long and short of it. But if you mess with those, you're going to mess up your Azure Backup. And in particular, if you put a lock on that resource group, then you're going to, again, break the backup. So just don't mess with those resource groups. That's the key message there. And we mentioned already, migrate to the V2 schema if you're using the V1 schema. Okay, that's it for Azure Backup. We're going to move on to Azure Site Recovery. Let's just take a 30-second pause there, and we'll come to Azure Site Recovery in 30 seconds. Do put any questions in the chat for Azure Backup. Okay, Azure Site Recovery, let's move ahead. So remember, this is Azure Backup was all about our data scenario, long-term retention, data corruption. Azure Site Recovery is if, my site burns to the ground, or I'm hit by some other massive disaster and I need to get up and running again in a new location. So let's have a look. So Azure Site Recovery is Azure's disaster recovery solution, and it covers a ton of scenarios. Again, like Azure Backup, it's a hybrid solution. It covers the Azure story, but also running things on premise. That could be Hyper-V, VMware, physical servers, even other clouds, whatever it is, it can all work with Azure Site Recovery. So let's have a look at that. So I won't talk too much about the on-prem scenarios, but it can work for both. Here we see Azure Site Recovery where you're running an on-premise scenario and your disaster recovery site is also on-premise. It's so you're synchronizing data between your sites, and Azure Site Recovery is simply a coordinating service to enable this to happen. And that can work on both Hyper-V and VMware. So this is a purely on-premise scenario using the cloud as a coordination orchestration layer. And then you also have the option where you say, okay, I have my on-premises sites and I want to fail over to the cloud, where obviously this has huge cost savings, because whilst you're paying for Azure Site Recovery, you're not paying for that secondary site, physical site of your own. So, so this is where it's the failover to Azure. And for many companies, this is a starting point on their cloud journey to look at Azure as a way of improving their resiliency story. Where we're going to look more is on this scenario where we deal with replication and failover between sites. So here you can see it's South Central US to North Central US, but it could be anywhere to anywhere. You can do this from Norway to Japan if you like. You can do this across any regions. So so let's have a look at how this works. The high level, to set this up, you're going to go through a few different steps, and I'll talk more about these steps in a few moments, and we'll look at a demo. So you're going to create the vault, just like the backup vault. It's the same vault, and that's typically you put that into your target region. In the backup, it was in your same region as your source. Here, it's going to go into the region of your target. Now you're going to have a bit of setup, and the setup, I really think of it in 3 bunches. You're going to do some networking setup, and that includes configuring things for your target, but also there's some network stuff that needs to be set up correctly in your source network. So we'll do some network setup, and then we're going to look at replication. You need to set up replication over VMs, get them replicating their data. And unlike backup, as we saw, it was like a snapshot that was like a once a day snapshot. This replication is a continuous replication to keep your recovery point objective low. You know, it's going to replicate the data incrementally, continuously. So it's a very different to the backup replication we talked about. And then we talk about the recovery plan. We're going to talk about how we set that up, and that's all about, you know, how do I recover my machines? You know, what order do they have to come back up in? Are there any special custom steps required for the recovery? And then when that's all working, you think it's all good, you can test the failover without doing a real failover, and we'll look at that. So so the networking setup. On your existing source network, there's a few things you're going to have to set up. In particular, it needs access, outbound access to the vault, and a few other bits and pieces in Azure to get that outbound networking to work. So they have good documentation on this. If you're doing this in Azure, you can have service tags that you can use to set up the appropriate outbound rules on your network security groups. If you're using Azure Firewall to control outbound connectivity, you can use URL-based rules, and again, it's all in the documentation. And you need access to Azure Storage, and you can use a service endpoint there, because that's a good idea, because if you don't use a service endpoint to Azure Storage, then if you're using a network virtual appliance or Azure Firewall, or if you have forced tunneling through an on-premise network appliance, then all your backup data is going to go through that appliance, and you don't want that, because that's a lot of data that you're going to be hammering through that appliance. You're going to get throttled. It's not going to be a pretty sight. So what you need to do is set up a service endpoint, and a service endpoint is, we won't go into a deep dive on networking here, but you set up your service endpoints, and that effectively creates a route directly to Azure Storage that will bypass your network appliance, bypass a firewall, bypass the forced tunneling, so that this channel to the Azure Storage is not going to get throttled and so on. Okay, you then set up what's called a network mapping, which is a mapping to say, look, this is my VNet in Azure that my source is running in, my existing application, and then this is where it's going to fail over to in a disaster. So you create a mapping between those networks and subnets. And then you can also fine tune the network settings at a VM level, where you say, okay, exactly which subnet is each VM going to land in, what network security groups do they have, IP addresses, load balancing, and so on. So there's a whole bunch of settings you can fine tune there to make sure that that's set up just the way you like. That's the networking side. Replication, you're going to specify the replication policy, which is how long are you going to keep these recovery points? Now, these are incrementally, continuously updated things. So typically the default is 24 hours that the recovery is for. We're not looking here like backup where you keep data for years on end. This is all about just failover with the current data. So typically you have a 24-hour retention on the recovery points, and it will do an app consistent snapshot at a certain frequency. Default is 4 hours, and then it will just do incremental updates on top of those. So that's how that works. You have an option here for multi-VM consistency. Now, don't use this unless you need it. But if you do have an application that has a workload that requires multiple VMs to have a consistent backup across those VMs, you can enable it here. It's expensive computationally. It may impact performance. So don't do it unless you have to, but it is supported. And there's an extension that runs on your VMs to do this, to do the synchronization, and you have an option to specify whether that extension is updated manually under your control or whether Azure Site Recovery can take control of that extension and do those extension updates for you. So you have an option for that. And then the last one on the recovery plan, okay, I have my data replicating. What about the recovery? This is where you can define what order things come back up in, and you can also define custom steps here with PowerShell scripts, for example, to say, okay, after the VM has come up, I'm going to do some extra configuration on that VM. Maybe I'm going to, I don't know, put it into a load balancer backend pool, and you can do that automatically for internal, but for external load balancers, or maybe I need to associate it with an application gateway, for example. Maybe this VM sits behind an application gateway as a custom step. The VM has come back up, but Azure Site Recovery won't configure the gateway for me, so I'm going to set up the application gateway, and I'm going to put the VM into the application gateway. There'd be good examples of custom steps that you would do with PowerShell scripts. So you can set that all as part of your recovery plan. And then you do a test failover. You keep your application up and running, and you do a test failover, and it will just use the replicated data to spin up this new environment using that recovery plan. And you can do this in a separate network segment, if you like, a separate subnet, a separate VNet. And you should check that this all comes up cleanly, or everything comes up in the right sequence, everything, all your custom scripts are working, and of course that at the end of it, the application works. You can then do real failovers, of course, and you can also do failback, and it will replicate data in the other direction. And of course, while it will do the failover, at the end of the day, you will own cutting over the endpoint, the customer endpoint, whether that's a DNS change or a network change or whatever it is. You still own cutting over that endpoint so that the customers hit the new service. Now, of course, you can use a custom step to automate that. Maybe it's a DNS change and you do that automatically, but that is your responsibility to do that cutover. Let's have a look. This is easier to understand from a demo. So let's have a look. Okay, I have this resource group, CloudShop RG2, where I have deployed an application which has got 2 web servers and a SQL server all running in VMs. And if I just look at the IP address for this, if I copy this and just open it in a new tab, you'll see, there it is, it's this thing called CloudShop. There's my application running. It's not an interesting application, but hey, it works. So let's have a look. How would I set up site recovery for this application? So this, first of all, it's in West Europe. I'm going to do replication. I'm going to do a site recovery to North Europe, which means I need to go to a vault in North Europe. Backup would be in West Europe, but and this is actually it's VMs from here that you see those, because I have that policy in place that does the backup deployment automatically. This is where these are showing up in my vault for West Europe as backup VMs. My policy assigns them automatically, which is awesome. Let's have a look anyway, the vault, and let's have a look at North Europe. And in here, I will set up site recovery. So I just go into the getting started. Let's use the wizard, set up site recovery. Now I have, you saw I have this is CloudShop RG2. I have a second copy of this CloudShop RG, which is already replicating. So I've done this twice, just to save us time as we go through the demo. So let's look at the site recovery here. And you can see here, prepare infrastructure. This is only on the on-premises side where you need to deploy whatever you need on-premise that integrates with, backup servers and all this stuff. But we can forget about all of that for the on-premises scenario. We are just going to replicate the application here in Azure. So we'll specify the source, that's Azure, and the source location is West Europe, that's good. And resource manager, it does support classic, but we don't care. So, and it's same subscription, and you can actually do a source from a different subscription. And here we're going to say it's CloudShop RG2 is where everything lives. and we'll choose our VMs. If your VMs are in multiple resource groups, you can still do it. It just doesn't work so smoothly with the wizard, but you can still do it through the other UI. We'll say, okay, those are the 3 I want to replicate, and okay. And it can do this off default settings. So it'll just give me a whole bunch of default settings to say, yeah, we're good to go. Or we can now start to fine tune it a little bit, like, oh, maybe we want to replicate to a different subscription. You can choose a different subscription here. Or we could say, customize the network and so on. So if I click customize here, you can say, okay, here's my target resource group. It's going to go cloud.rg2, and it by default uses this -ASR suffix on the target resource group. Maybe I want a different name on my resource group, so I can change that here. I can look here for the VMs. I can say, look, is it going to be a standard HDD or premium or standard SSD? I can tweak what my disk is here. I can choose the cache storage account to use for the replication. I can choose here availability sets or availability zones for the different VMs. So there's a lot of settings I can tweak here if I want to. So that gives me a certain amount of control. There's more settings we'll see later. And the other thing here is further down. So that was the storage and network and so on. There's this replication policy that I can tweak here. So here's where I choose my, it's 24 hours retention and a snapshot every 4 hours, but it'll do incremental data continuously. And then here I can do the multi-VM consistency that I mentioned. I'm not going to need that, but that's where it lives. You can't set this up later, so this is where that lives. And then also the extension. If I want to control whether that extension that gets put on the VMs is updated automatically, the default is that you can see allow ASR to manage. And that's managed. Those updates are pushed out using Azure Automation. So it needs to create an Azure Automation account, which it will do for you. But you can also specify your own automation account if you have one. But this is, or you can choose to say, look, I'm going to manage these manually. They support up to the last 4 versions of the update extension. So if you are managing it manually, then you are responsible for staying within a supported version. Okay, so let's leave all this at the settings we have, and we just say create target resources, and this will create all these configuration settings for this, and then we can enable replication. So this will turn on the replication. It will run the replication jobs. Now, replication will take several hours for this, which is why I have one that is done already. If we go to replicated items for this vault, you can see these 3 VMs. Now, these look like the ones we just talked about, but actually these are from a different resource group. These are from the cloud.rg resource group. These ones are working, and you see they're fully protected already. The new ones in a few minutes are going to appear in this list, and it's going to show their status. They're replicating. It'll say that, they're 5% replicated, 10% replicated, and so on, until eventually they come through in the protected status. So they will appear in this list at some point. Not yet, there'll be a few minutes. But we have these ones replicated already, and this is where you can check that their status is good. If I drill into one of these existing VMs, if I go into Web VM 1 here, you get this overview of the setting. There's a little picture even of showing how the replication is working, where it's going from and to. And here is where I can do test failovers and failovers at the individual VM level. So I can do an individual test failover here. And I can also look at properties on this VM. And in particular is these two tabs here, compute and network and disks. These are super important. So compute and network is where I can fine tune my network settings. So I can see here the resource group, some of those settings I just saw. What size of VM is it going to be? What availability set? And I click edit. I can tweak this stuff later on. So I can say, look, this is how this is going to, come back up for the target. So what size is the target? Availability set. Here you can say which network does the test failover go to, which network does the normal failover go to. The test failover isn't configured by default. The normal failover the network will be created for you, but the test failover network you have to create yourself. We'll look more at that in a second. And here again, I look at the individual NIC level. I can go in and I can configure, do I need a static private IP address, for example? I can join it to a load balancer, though I think this only supports internal load balancers. If you want to do a public load balancer, you'll need to use a script. We'll talk about those in a sec. Network security group settings and so on. So there's various settings you'll need to tweak here to make sure that everything is going to come up the way you want it to. Okay, so there's all these settings, and then similarly the settings for the disk, what size of disk and so on. So these disk settings are here. Okay, so that's that, and you can do that. You can look at these settings for each of your replicated VMs. Okay, you can see the other VMs are appearing now, the enabling protection. These are the new ones I just configured. So the next thing to look at is the replication plan, the recovery plan. So this is replicating everything, but the recovery plan is where we control how things will come back up again. Now, and recovery plan doesn't get created for you by default. You can do the recovery without a recovery plan just by recovering individual machines. But here I have created a recovery plan, which I created manually. For the new thing I just did, the backup I just set up, the replication I just configured, you might come in and you'll create your own recovery plan. But let's look at this one I created already. And here you can see that this is set up for those 3 machines that are replicating healthily. So this is set up for those machines. And if I want to see the plan, the best thing is to just click this customize button. You can have a look at the plan. And you can see what this does. I've got all groups shut down, so everything shuts down. Failover, this is just telling Site Recovery about the data replication, stopping the replication, and so on. And then here to start the machines on the other side, and the data that's been replicated is going to be used to spin up the disks on the other side. And here you can see I've configured these machines into groups. I can say, I can add new groups, and I can configure here, look, the SQL VM starts before the other VMs, and it's straightforward to just add another group onto this list and remove a VM from one group and add it onto the third group. I could say, look, don't put this machine here. I can, add protected item, VM2, this one, okay here. And I can rearrange what order my machines come up in. I'll discard the changes, but you get the idea. So this is how we configure our recovery plan to control how things come up. And I can also add pre and post actions here before and after each group, where I can say, a script or a manual action. There's something that you may want to do just manually, and you have to go and confirm that it's done, or you can have a script here where you run a script in Azure Automation to automate some part of the setup. Okay, so you get the idea there. That's my recovery plans. Okay, so let's close this. You saw I could do it. There was a button to do a test failover at the VM level, but one of the advantages of having a recovery plan is that now I can do a test failover at the application level across all of the VMs. So I can do that. If I click test failover, it will just confirm this is from West Europe to North Europe. Use the latest recovery point. I can use others if I like, and I can choose the virtual network, which will be the test virtual network. And you can see here, this is the, you can also fine tune this at the individual item level. But anyway, we'll choose the test virtual network and then OK. And that's it. That's going to kick off a test failover. Let's have a little look at what resources we have floating around now. So in my cloud shop, if I look at my cloud shop, you can see this included a load balancer and a public IP address for the load balancer, virtual network, and then it has the VM and the NIC and the disk, VM and the NIC and the disk, and so on. And then there's a NS network security group on the network as well. So this is my starting point. This is what the application actually consists of. Now let's have a look what was set up for me. So when I set up the replication, what did it do? It's creating the network, creates the availability set, and it's creating these replica disks, but it doesn't create the other things. It doesn't create the load balancer, it doesn't create the network security group. There's a certain amount of work that you need to do to build this landing zone for the replicated application. You need to go and create load balancers, IP addresses, and so on. You need to create all that. And if I create the load balancer here, then I can go back into those settings and associate the VM with the load balancer, so the VM can come up associated with the load balancer. Although, as I say, I think that only works on internal load balancers. So otherwise, you can create resources here and then tie them into your automated scripts. But you need to build the landing zone. During the failover, it's going to run your scripts, and the other thing it's going to do is it's going to do your disks and your NICs and your VMs, but it's not going to do the other stuff. So you need to build that landing zone, configure your NSGs and whatever else needs to be part of this world. Load balancers, application gateways. Maybe you need on-premise connectivity and you need to connect this in. Maybe you need to do a peering connection to a hub spoke in a hub spoke network, where you need to peer with a hub that has a VPN connection or an express route gateway, and so on. So there's a lot of other stuff you may need to do to make this a viable environment. is your governance in place? Do you have RBAC? You know, whatever. You know, everything you need to kind of make this a sufficiently well configured place that you're willing to have your business depend on it. If I look at my CloudShop RG ASR, this is the new one that we just set up the replication for. The one here without the number 2, this is the one I set up earlier that we just kicked off the test failover for. So if I look in this resource group, you'll see here I have the disks here for the ASR test. You know, these are coming up, and the network is here that I created manually for the test network. And there's an IP again that I've created manually for those. And this is where my test environment will land. Now this will take, I don't know, maybe 10 minutes or so for those test VMs to land. So we'll pause the demo at this point. We'll go to the Q&A, and if we have time, we may come back and see if the test failover has worked or not. But I'll pause there for now. Okay, so there was a question there, and what's the difference between the failover and test failover? So the test failover is intended to enable you to verify that your replicated data works and all your scripts and everything work without disrupting your normal application. So replication will continue in the forward direction while you do your test failovers. Whereas when you do a real failover, you're now going to fail over to the new application, and you're going to be using that as your production environment. And you may want to do a fail back, and that includes fail back to your on-premise environment. Don't forget, you could be on-premise to Azure and then Azure back to on-premise. So with the real failover, it's going to set up reverse replication. It's going to stop the forward replication. It's going to set up reverse replication. So you can do a fail back again. So that's the main difference there between those two worlds, and as well as being able to configure them to land in different networks and so on. Hopefully that answers that question. And there was a question there on the network settings. Yeah, I think hopefully did you see the settings? I think we covered them in the slides, and then we hopefully you saw them in the demo. Do I need to go back to those network settings, or did they come through okay? I think we looked at them in the demo. Okay, hopefully that covers that. Does that work for everyone? Does that answer any questions people have? We've covered the main parts of our talk now. So you can see we've done availability, backup, and site recovery, and we're into the Q&A phase. I'm happy to go back to do the demo on the file level recovery. And then the network settings. So let's do that. So let's just go back in to the ASR. So if we go back to our vault, I'll just find it in my vault, in my West Europe vault. The settings we had, if we look at our replicated items, which we should have, I'm in the wrong vault. It's the North Europe vault. Because of course we're going from West Europe to North Europe. Okay, there's my replicated items. You see here 0%. These are the ones I set up the new replication for, 0% synchronized. You know, there'll be a while. These ones, clean up test failover pending. Okay, so these ones looks like the test failover is completed. So that's good. We'll have a look at that in a moment. That's been nice and quick. So okay, if I go into an individual VM, within here, you then have this computer network tab here. I mean, there's a summary that you get to see, but computer network is where the detail is. And here you can see what size of VM would it be, availability set details and so on. And then here, the network that it's going to use, and then an individual NIC where you can see individual settings for IP addresses and load balancers, network security groups, and so on. So if I click edit, you can then edit this stuff. And here you can see I can specify availability sets. I can choose the networks that we have. For these networks, actually, there is a feature I didn't show you, just while we're on the network settings. If I go into the site recovery infrastructure, now most of the settings here, many of these settings relate to the on-premise scenario, but there's these 3 sets of settings up here where I have the extension update settings. We saw these when I went through the wizard to set things up, but this is just for the site recovery to manage the extension. The replication policy I can access from here. This is the policy that says, okay, it's a 24-hour retention and 4 hours for the full snapshots. And then here, the network mapping is something the way you create a mapping between your at the VNet level. You say, look, this VNet maps to this other VNet, you know, my source and my target environments. Azure will then make based on that VNet mapping, it will create individual mappings for individual IP addresses, you know, as a suggestion. But you can override those individual VM level settings at the VM level. So this is where you set up a network mapping between your source and target networks. So you create that. And this you set up in both directions. You set up mapping both ways. That was in your site recovery infrastructure. That was here. And then in the replicated items, you can drill into the individual items where you would say, okay, for this VM, compute and network, edit, and then go into the NIC edit. And you can now poke around and say, okay, I want to assign a static IP to this VM. What should it be? And you can put that in here, 10.1.0.5 or whatever you want to choose. You can choose to have accelerated networking enabled if the VM supports it. And here's where you can tie your VM into the backend pool of a load balancer. Although, as I say, I think this only supports internal load balancers. You can set the network security group for the, you can see here, there's a subnet where you can set the NSG, and then this one is at the NIC level for the NSG. So, and you can do that for the test failover environment and for the full failover environment. So that's where you tweak all of these network details. Does that answer the question on the network? Yeah, full auto require. Yeah, okay, thank you. Yes, is there a way to do auto recovery without manual intervention? Yes, with a manual, with those automated scripts. So it'll like I say, it will spin up the VMs and the NICs and everything for you into your environment. And if it's a simple, straightforward single VM, hey, that's going to work. But you still got to figure out how you're going to get your customers to point to the new environment. And if it's a more complicated application, it may require some additional configuration. So for example, if you've failed over your database and your VMs, how do the VMs talk to the database, application talk to the database? Is that configured with a connection string that contains an IP address or a DNS host name? If it's a DNS name, is that going to be the same DNS host name in the failover environment? Did the VM name change? Did the host name change? Or is it on the IP address? Did the IP address change? So you might be having these manual steps where you need to tweak a connection string. You might also then go think about how the endpoint that the actual customers use to get to this application. Is that a DNS name? Does that need to be updated to point to the new IP address of the public IP of the service? Or is it an internal DNS for a line of business application? So all of those changes, you can then look at automating. Obviously, it's best if you can just keep your environments consistent so that, you know, the names, you know, you minimize how much of this reconfiguration has to happen between environments. But where you can't get rid of the reconfiguration, you have a choice then, do I do it manually, which is fine if you want to, or if you want to do it automatically, you can use those custom steps. So let's go back to those in the replicated, in the recovery plan. If I go into the recovery plan, I can, actually, I can't edit it right now until I do cleanup test failover. When it's in test failover mode, the recovery plan is locked. Will it let me see it? Items in the plan, they're just the items. No, I can't view it without let's come back to it when I've done the test, looked at the test failover. In the meantime, let's just have a quick look at that, what has been done with this application. Let's have a look. If I look at my resource groups, this is the one that we're failing over into. Here we can see that we have the test VNet, and look, there's all these virtual machines, SQL VM test, Web VM1 test. Now they haven't been attached to the load balancer. And just to save time, I'll just go in and look at, let's just access the application just through this one machine rather than setting up a load balancer for it. And to do that, networking, go to the NIC. You guys must do this 1,000 times. ipconfig, give it a public IP address. Is this one in use? I think these are available, so let's just use them. So save. We'll give that a minute or 30 seconds to just put that IP on the VM, and then we can just hit that VM on its IP, and we should see the application is up and running. Fingers crossed. Always nice when it works. Okay, just wait for that to save. The question there was, yeah, how will the script trigger when a VM fails? So it is up to you to press the failover button to trigger a failover. Now, as with everything in Azure, Azure Automation is your friend. If you're not familiar with Azure Automation, it's awesome. You should go play with Azure Automation. It's a cool service. So if you don't want to manually press that failover button, and you believe that you have sufficiently good diagnostics that you are happy to trust that button to be pressed automatically. Some people want a human in the loop, some people don't. That's fine, I don't care. It's a business decision. Then you can create your own testing, your own process, whatever it is, and call that button programmatically. Azure Automation is one way to do that. Otherwise, I mean, the Azure SDKs are there. You could have PowerShell, CLI, SDKs, whatever you have running that can check your application health and fail it over, then that's an option to trigger that into Azure Automation, or just to call the appropriate recovery services vault method to API to trigger the failover. So there's ways you can automate the failover, but it's not built into the recovery services vault. It's something you need to build on top. Hopefully that answers that question. Okay, so this worked. So let's just go to the VM, and what is the IP? It's this. So let's have a look. The application should look like this. Let's see if the failover one, the test failover one, actually works. It's probably got that cold start thing with a new web application. It's doing its IIS cold start. So that's why it's probably taking a few seconds to load the page on the very first hit. Oh, look at that. That's just so awesome. So that is that. There's a question there, demo how we can trigger the failover automatically. I'm not sure I can do a demo of that today. I think it's quite an involved thing. So it would be some piece of work to figure we have to find the right PowerShell to trigger a failover and set that up in Azure Automation or wherever you're going to failover it from. We could look briefly and see if we can find the PowerShell command that would trigger the failover, and then you just have to find the right way to run that PowerShell command. I'm happy to just do a quick search for that. Trigger Azure Site Recovery failover. We could have just a quick, yeah, so here we go. I expect this will cover it for us. So this, do a test failover. Okay, let's have a look here. Okay, so here it's got the PowerShell to get the recovery service point, create the failover job, commit. Okay, yeah, so here we go. And then here's the failback to do the failback. But okay, so the PowerShell is here. And you can see here it's polling for the status of the failover job. Okay, yeah. So this is the PowerShell, how to do a failover programmatically, and then you would need to embed this within your own code, within your own automation to actually detect that you have a failover, and then execute these steps. Hopefully that answers the question. It's as close as I can get in the time we have, I think. It'd be an interesting thing to do an expert talk on Azure Automation, actually. That would be maybe an idea for the future. Okay, let's have a look. The other thing I was promised was to look at the backup, or the file level backup. We promised we'd look at that, didn't we? Let's, did we answer the other questions? Okay, hopefully that covers those questions. Let's have a look at that backup scenario again. So let's go back to our vault. Okay, this is awesome. This worked. And oh, we were just going to look at something else on the vault as well, weren't we? Because we had the test failover that we couldn't access. So after you've done a test failover, you should press the clean up test failover button. And that you can put some notes if it didn't work. Test is complete. Okay, yeah. So this will delete the test failover machines. So that will do that. And when that's finished, we can go back into this customize the recovery plan. And then here is where you can set those scripts that run during the recovery. But I don't think we need to look at them. I think your question was more about how you trigger the recovery in the first place. So yeah, so detect the failover automatically. So is the question, how do you detect that your application has failed in your primary site? Or is the question, how do we detect that someone has done a failover? The how do you detect that your application has failed in your primary site? That is a good question. You can have your own polling that might hit that application and verify that it's working. You could also look at using diagnostic logs, maybe from the load balancer, to see if that is working. There's no kind of built-in way in Azure to just monitor the health of the application and trigger the failover. You should look at having your own, maybe in Azure Automation, you can just do a get against a URL that the application runs, and you could have an Azure Automation that runs every minute or every 5 minutes that does a get request against the application. If the get request is failing, or maybe if it fails 3 times in a row, then trigger the failover operation. So you'd have to build something there to trigger that, to do that detection and failover. There's no straightforward way, because a lot of it depends on what your application is and what constitutes a failover. It's a logic that you need to build around the specifics of your application. So sorry, I can't give you a more specific answer on that one, because, like, as I say, it's something that you need to build, I think. Let's have a look at the backup that we promised we'd look at. So let's just go back to our vaults, which I can get to here. We'll look at the West Europe vault. That's where I have my backups, and I have my backup items. Okay, I have my VMs. Here they all are. Let's have a look at this one here called test VM. And let's suppose I want to do file recovery on test VM. So, okay, this is what it's giving me. Download the executable, and then it's going to be a password that it's going to paste here. So I need to select the recovery point. Yeah, latest, that's fine. So, okay, so if I download this executable, okay, this will take a minute. In the meantime, while that does that, I'm just going to RDP into a VM. It doesn't have to be the same VM. We can RDP to a different VM. So I just don't want to install it locally on my machine, because I don't want to mess up my machine. So let's just have a go here. If I look at my VMs, let's just pick something that's running. So this one here, test VM2, is in the same region, West Europe. Okay, so let's go to test VM2 and connect. And that's just prompting me on the other page for my credentials. Oh, what do I make this of the network enabled? Bear with me. It's a Linux machine. Oh, I'm not going to do that. Let's choose a different one. What's this one? This one's a Windows one, and it's running. So let's try this one. RDP. Okay, connect. Hopefully I've got the password for it. Yes. Okay, so I'm just remote desktoping to this machine on the other screen. I'll bring it over in a second. Okay, so if I go back to that file recovery tab, you can see here, okay, script is ready to download, and I'm going to download that script. It's there it is. And I'm just going to have a look at that. You know, that's just here in File Explorer, there's the script. Here's my test VM, the one I just RDP'd to, not the one that the backup was taken from, the one I RDP'd to. And what I'm going to do is I'm just going to copy that file across, that script that we just downloaded. I'm just copying that across here. So if I run this, it's then asking for that password. So if I just come here, password to run the script is here, copy. And now I go back to the machine here and paste. This is doing what it does. Let's just get rid of that server manager. We don't need that guy. Okay, here we go. Let this run. And this is mounting, remember that this is taking the backup and it's mounting it as a drive on this machine just so I can copy individual files out of my backup. So there we go. Connection succeeded. Sounds good. Please wait while we attach volume to the recovery point. And one of the tricks is don't close this window. Just leave this thing open, yeah, while you're doing this. And when you're finished, you do that unmount disks button back in the Azure portal. Okay, so leave this, and you can see here two volumes attached, F system reserved and G Windows. So let's have a look what we have here. So it's now mounted the backups as these extra drives. Look, that was a system reserved volume that was on that machine. Probably nothing interesting in there. Let's have a look in the Windows. This was the OS disk, I guess. And look, now I can poke around the backup of that I took from that backup. So hopefully that answers the question we had earlier on how to do the file level restore. And it's just a drive, right? So I can just take any file I'm interested in out of here, poke around here, and just, you know, whatever they've got, I can go in and take. Do I have anything here interesting? No, it's pretty empty, isn't it? Because it was just a clean VM. I didn't have anything interesting in it. But you know, no one's even logged into this. No one's ever even logged into this VM. But yeah, we can just take I mean, whatever it is, you can just take a file and copy it from your backup into your wherever it is your environment you're trying to recover into. So it just lets you cherry pick those files, and it works. So that's that. So when you're finished, like I say, I recommend doing this in just some temporary VM, because mounting these drives, you know, you don't want to mess up your day-to-day box. But you you copy the files over, and when you're done, unmount disks, and in the VM, well, I don't care what happens. It's a temporary VM. I'm going to throw it away. So that is how that works. Okay. Okay, so that was that. Okay, and then the question was just on this, we've been laboring this question, kind of failing to answer on detecting application failure in Azure. So I guess, yeah, you do have in Azure the ability to look at the health status in Azure, and there are APIs you can call to look at the Azure Health, but there's no integration from the Azure Health through to the Azure Site Recovery failover. Again, you could pull those APIs from Azure Automation and use that to trigger the failover, but there's no built-in automation then. Typically, I mean, from having worked on various, you know, Azure services on the inside, often this kind of outside-in monitoring, where you're simply pinging your application from the outside. In Microsoft, they call those runners. But those are often the most reliable way of detecting some kind of end-to-end failure. To detect failures within the applications can be good, but it can also lead to a lot of false alerts. You get, because you have a lot of, we talked about high availability at the beginning of the talk, didn't we? And resiliency by having redundancy across the application. So because you can then have failures that might affect one VM, but you've got two of them, so it's okay. It's like, well, does that trigger a failover or not? Or how do I know if both of them have failed? You know, it can be a pretty complex logic to determine whether a failover is appropriate, especially something like a failover, which is a pretty big deal to do a failover. You know, you don't want to do it at the wrong time. You don't want a false positive. So to avoid false positives, I think it's a case of leaning towards outside-in monitoring, where you actually ping the application and do some kind of check of the application itself, and perhaps manual failover, if, again, depending on the criticality of the failover and the recovery time objective you're trying to meet. Hopefully that answers the question that we've been laboring. Apologies for it. It's the best I can do. Okay, super. Yes, you're just being polite. Okay, that's it. I think we are done. We ran a little over time, not too bad. And with that, I hope it's been useful. Thank you everyone who has attended. And we will have a recording of this. We'll put the recording up, we'll clean up the recording, take out all my ums and ers, and we'll put the recording up on Skill Me Up for you to look back on, or for other students in the future. Thank you very much.